I'd like to now look at an application problem of a side-side angle triangle. In this example, it says that to measure the height of a mountain, a surveyor takes two sightings of the peak at a distance of 900 meters apart. The first observation results in an angle of elevation of 47 degrees. The second in an angle of elevation of 35 degrees. Find the height of the mountain. First thing we're going to do is draw a picture of our situation. All right, so let's assume for just a moment that the mountain is here. Okay, here's the peak of the mountain at the top. Okay, we were told that the surveyor took two different sightings. Let's say that he took a sighting from this point, and let's say he took a sighting from this point. Those 2 points from the problem was told to be 900 meters apart. Okay, from the sightings, you're going to be looking from the point straight up to the peak. From this sighting, you're going to be looking at the point straight up to the peak. Now what I'm going to do is I'm going to clean up my mountain. I'm going to drop a straight line from the peak of my mountain down so that I can create some triangles and use those triangles to solve my problem. So this is representing the mountain's peak, and then I'm going to draw a line straight down so that I've created two right triangles with this drawing. Okay, I have one larger right triangle from the first point, and then I have one smaller right triangle from the second point. Okay, now they told us something about the angle of elevation for both of those sightings. Now they didn't tell us which was which, but you can figure out which is which from the measures. Think about from the first sighting, from the point farthest away, you're going to have a smaller angle of elevation in there. So this one has to be the 35 degrees. Okay. And the second point, the second point we sighted from, we're closer to the peak of the mountain, and so that angle is going to be larger. That would be the 47 degrees. Okay, now from here, we can find a little bit more information. Let's first of all let h be the height of the mountain, what we're interested in finding. And let's let c, I'm actually going to let c be the distance from here to here. All right. From that, we can first work on an actual obtuse triangle in here. Okay, and then the distance down to here. In that obtuse triangle, we can actually go through and we can figure out the other sides, or the other angles. This angle in here, I can compute because I know the angle just to its right. 47 degrees is the angle to its right. So to compute that angle on the other side, I can take 180 degrees and subtract from 47. Okay, that would result in 133 degrees. Now that I have those two triangles in this obtuse triangle I'm drawing, I can also compute the angle in the top. The angle in the top would end up being 180 degrees minus 35 minus 133. That results in a 12-degree angle. Okay, now given that particular information, I can find the length of side C. How will that help me? Well, if I can find the length of side C, then hopefully eventually I can also find the side of H. Okay, so let's tackle trying to solve that. So first of all, what I'm going to do is I know the 900 meters. The 900 meters is actually opposite of the 12 degrees. So those two pieces of information goes together. I use sine of 12 degrees divided by 900. Now I wish to find side C. Okay, the problem is which angle is opposite of side C? Well, the angle opposite side C is the 35 degrees. Okay, so we have sine of 35 degrees over side C. Okay, to solve for side C, I'm going to multiply both sides by C to begin with. That will cancel that out on that side. And then I have C times sine of 12 over 90, and then that's equal to sine of 35 degrees. I then multiply both sides by the reciprocal of what's behind C. So C would equal sine of 35 degrees multiplied by the reciprocal of what I had behind the C, which is 90 over sine of 12. Okay, we'll type that into our calculator. We'll end up with C equals 2,482.875257, and that measure should be in meters. Now, leave that number as exact as you can possibly get it, because we're going to have to use that number again. Now, scrolling back up to our picture, you see that side C is actually opposite of our 90 degrees. So we can put side C and 90 degrees together as a pair, and then 47 degrees and side H are opposite of each other. And so we can solve for H using the law of sines one more time. So we will have here sine of 90 degrees over the value that we just got equals sine of 47 degrees divided by H, which we don't know. Okay, once again, to solve for H, I'll multiply both sides by H. And then I will also multiply both sides by the value that's now behind H. Okay, I'm going to skip a step here. So H will equal sine of 47 degrees multiplied by the reciprocal of what was there behind H, which was this number, divided by sine of 90 degrees. And so we'll end up with the height of our mountain is equal to 1,815.86001 meters. Okay. This concludes this example on solving applications having to do with side-side angle triangles.